All right, well, I will begin, and I'm not 100% sure I'll manage to be able to post this on YouTube because I'm not 100% sure I can get the video off the phone, and this is, I forgot my camera.
You can send it to your computer, I'm sure it'll work like that.
Yeah, these are all hypotheticals, but yes, if you believe in technology, it'll work, but I don't share your beliefs. So, so I want to show you how to graph this polar equation, and I'm going to go through the technique that I went through at the end of last class, which I annoyingly never pivoted the video camera over to look at. So if you're watching the video from last Friday, the last 10 minutes of class, I was annoyingly like over here, and all the work was over there. So the audio is all there, and you should get notes from somebody if you missed it. But here it is, this one. So what I described basically was simply this. First of all, we're just going to draw a graph of, r versus theta. All right, so, and I already regret what I wrote there, because it's 2 plus 2 cosine theta, right? So everything that's going on there that's interesting is happening above the theta axis, right? Because 2 plus 2 cosine theta, it goes from 0 to 4, if you think about it for a second. And so, like, smart thing to do would be a graph more like this. All right, so it starts out at 4, right? Here's 4, here's 2, all right? And I'll make this 2 pi. And let's see here, in the middle's pi, here you got your pi over 2, and here you got your 3 pi over 2, and I'll just leave it at that. And so, if we think about graphing cosine, it starts at 1, right? So 2 plus 2 is 4, and then at pi over 2 it just drops down to 2 because cosine of pi over 2 is 0. Cosine of pi is minus 1, so 2 minus 2 is 0. And then go back up to here, and then finally back up here again. So it's just a shifted cosine, right? So we should all be able to do that kind of graph, right? And if when I assign this on like test 3, I'm going to try to make a page which already has set out for you like the r theta axis, so you can just add it to that. And like my intention, if I assign this problem, is actually to give you like a graph paper where you can graph sine and cosine on top of it. Because just freehanding these stuffs on paper, I can't really judge too much what you're doing because people are just not that neat. But if I give you graph paper, then life's a little bit better, right? So then once you have this, then we draw our xy graph, right? And so we're going to use this up here as a template on how to go. And so what happens? We start at radius, 4, when theta equals to 0, right? So let's, I'll use my hand as a reference. This is going to be 4. So I'm going to set that to be 4. So this point right here, and I'm going to track I'm putting labels here. So this point A gives me this point right here, because this is theta equals to 0, right? The x-axis, the polar axis as we call it. Then pi over 2, we drop down to radius 2, right? So half of that. It's about like here-ish. That's at pi over 2, right? So I'm going to call that point B. So that's at B, right? Then what? Going from pi over 2 to pi, you do what? You drop from radius 2 down to radius 0, right? So if this point is C, this point is C, right? And so I'm just going to go ahead and hazard a graph here. It's something like this. All right? But I would like to point out to you, yeah, we could keep using the graph, but we kind of already know what's gonna happen. Because this has what? If we replace theta with minus theta, what happens? Notice that this is equal to 2 plus 2 cosine minus theta, right? Because cosine of theta is equal to cosine of theta. Cosine's even, and this shows that this graph has asymmetry with respect to the polar axis, right? So actually we know that if this is the graph above, then it's just gonna reflect down. But of course you can also follow the graph, right? Like point D here gives you 3 pi over 2 down here. Right, and then as you go back to point A, this right here, you know, let me call it E. A is equal to E geometrically, so we just kind of go like that. So this is called a cardioid, because it kind of looks like a heart. Any questions? All right, so let's look at another example. Let's see here. R equals to, let's see here, 3 plus 2 sine theta. All right. So first of all, think about it for a second. 3 plus 2 sine theta. Well, again, everything interesting is happening what? From 3 plus or minus 2. So the y's range is just, you know, I want my theta down here because everything's going on between 1 and 5, basically, right? And in the middle you got 3. So we've shifted the sine graph up 3 units, and then of course it's stretched out by 2 as well, right? And what does sine look like? Like that, right? So this point here is pi, 2 pi, you know, pi over 2, and 3 pi over 2 again. So let's see here, what goes on? Let's see here, at starting at theta equals to 0, we're at radius 3, right? So we're going from radius 3 to radius 5, so I don't know, I'll do my best. This is going to be 3. So there's your A. And then we go out to radius 5, something like here, at B. And then we drop back to radius 3 at pi. Right? And then what? Drop down to 1 at 3 pi over 2. Now that is, so it should be like 1/3 of those distances, so something like this, right? Yeah, this is, and then again, E is equal to A again. So these are very similar. They don't always work out like this, right, guys? So what's happening here is something like this. So it's kind of like you took the cardioid and just kind of like blew that out or something. This is what's called a limicon. And they put a funny symbol on one of those. I don't know how to do that, but this is French for snail. So if you think this looks like a snail, then you must be French, I guess. Anyway, this is limicon. Okay. Now if you read the section, you read the textbook, right? They give you some sort of like general parameters. For example, anything of the form r equals to a plus b cosine theta with a over b equals to 1, like anything of this form is going to give you a cardioid. And anything of the form, there's actually 4 different cases for cardioid. I'm just writing down one of them, but anything of the form r equals to a plus b sine theta with 1 less than a over b less than 2 will give you one of these quote unquote one loop limicon. And again, this is one of 4 possible formulas, but you see I fit the bill here, right? Because my A is what? My A is 3, my B is 2, so it's 3.5, 3 over 2, which is 1.5, right? So I fit into that case. So like I started with the textbook's result and I chose A equals to 3 and B equals to 2. I knew we were going to get one of these because I trust the book. All right, let's look at another one. Like, didn't you say you're going to go on to vectors? Well, I did, but I can't in good conscience do vectors with the current video in here. And like people are gone, so I'm going to just do more examples of this because I think it probably doesn't hurt. Because these you need to see. The unfortunate thing about these last 2 examples is r has been positive. There's been no negative r, but negative r can happen, and it's a little bit tricky. We saw that at the example of last class, and I will do one with negative r here before we're done. It may not be this one. No, this one's positive r again. Okay. So here we have r equals to 2 plus 5 cosine theta, all right? So here, if you think about this, we've got, oh, wait a minute, no, I was wrong. 2 plus or minus 5, right?
7, 3.
Yeah, we got 7 and minus 3, right? So we're actually ranging from 7 to minus 3. That's good news because that makes it more exciting. Let's see here. So we're going from 7, which I'll say is up here, right, to minus 3, which is about right here. Right, and right in the middle of that is where we oscillate around because we're on a shifted cosine, shifted and amplified. So we start at 5, we start at 7, right? And I'll just hopefully I did it right. I don't know, we'll find out soon. But this point right here would be pi over 2 and right here we've got pi, right here 3 pi over 2, and right here 2 pi. But we need to figure something else out here to do justice to this, right? Can you guys tell me, I need to figure out what these points are. These points are interesting. Whenever the radius is 0, it's interesting because that's the point where the graph comes into the origin, you know? So how would I figure out what these points are? I need to set 2 plus 5 cosine theta equal to 0, right? That should be where the theta that makes that 0, right? So that's cosine theta equals to minus 2 over 5. And I like to work in degrees, you know? So I'm gonna try to figure out what it is in degrees here. I better be in degree mode, I am, hooray. Inverse cosine minus 2 divided by 5, what do I got? Ooh, that one's big. So 113.6 degrees. Now for the purposes of the graph, if I divide that by 180, and I multiply by pi, I get, which is just about 2 pi. Just about 2 radians. So, I mean, that you can kind of see that. That's about where this is. Pi over 2 is 1.57 radians, so it makes sense that it's about 2, right? And then, what's the other solution? So that gave me this one, right? This guy. What's the other one? How do I find this one? What should I do? Yeah, I could try to find this distance, and then by symmetry, just add that to 180 or add it to pi. Another idea I had was this distance is the same as that distance. So I could just do like 360 degrees minus 113.6 degrees, whatever that is, you know. 246.4. So 246.4 degrees is the other place where we're, roughly speaking, going to radius 0. Okay, so, all right, so let's try to make the graph. So what I do is I start, here, and I'll label some points just to keep track of them, 7. So, and if you make your r theta graph to scale, you can actually just kind of like use a ruler and go, okay, I want this far here. So I just literally translate that down like that. And that gives me my first point. And then I go, okay, so pi over 2, I want that here. And then at pi, I want this, like that. And then at 3 pi over 2, I want that. Right, and then I'm back there again. And of course, a little bit past pi over 2 at, what was it, 113, so that's about 20 degrees past 90, so that's roughly speaking like right here. I go to 0, right? And about the same, less than 270. I got one like that, right? So this is the 113, and down here is your 246.4 degrees. I'm using those as guides for going to 0. But I gotta be careful, right? So notice, let me draw your attention to something. We can only directly draw these graphs. I said something wrong here. Let me label these. This is B. So I said B was here, right? Yeah. And then I said this point here was C. And where I put C was wrong. That's not where C belongs. Where does C belong? It's the right magnitude, it's the wrong side. C has R less than 0. See that? You're below the theta axis, you have R less than 0. That means we have to flip over the axis. So this point, it's not there, it's actually here. So sorry about that, my bad. That's what I was saying, you gotta watch out for the negative R, they're a little tricky. But then these other points were fine. It is D. And then of course A equals to E again. So what's going on here? We're starting at A, we swing over here to D, right? We come into the origin like that, right? And then what happens? As you swing over to C, right? Yeah, you're looping over here to C, and then you loop back to the origin again, like that, and then swing here down to D, and then swing back out here to A. So this is called an inner loop. Limicon. So it's in the same family of kind of curves as this, but you know, obviously a little bit different. Shall we do another?
When you get farther with your numbers, do you get more loops?
I suspect so. See, that's exactly the kind of thing I would go, so what you can do, really simple, go to Desmos, put an A here, put a B here, and just see what happens, you know?
Because if there's like a bunch of loops, I guess that's why they call it a snail.
Oh. Huh. So, what do you mean, like, just more and more and more loops?
I mean, yeah, just like a
With-
snail shell.
So like that?
I can see a shell.
Oh, you see shit? Ah.
And it's just sideways.
Hmm. Interesting. Okay, so, see here, we do another one. We can do R is equal to, let's say, 3 cosine of 4 theta. Okay, so everything interesting is happening between plus and minus 3. And 4 theta goes from, you know, what's the period here? It's 2 pi divided by 4, it's pi over 2. So it seems likely, I'm not sure exactly, let's just, I may regret this, but I'll put pi over 2 here, and put pi here, and I'll do that much. Okay, so pi over 2, pi, and so I go full cycle every pi over 2, so I'm gonna drop down here at pi over 4, right? Back down to minus 1, and pi over 8, I'm going through 0. I'm not sure if that's enough, we might need to keep going, so I'm just gonna do that much for now. And of course, you could trace this back as well, right? So this goes from minus pi over 8 to pi over 8. And so the first thing I do, and see, pi over 8 is 22.5 degrees, so that's pretty close to the x-axis. Something like this, roughly speaking. And I know how these things go, so I can tell you already it's gonna be something interesting over here and over there. And I'm using red so no one can see it except for you guys, maybe. Sorry about that. That was me actually drawing something on the chalkboard for those of you at home. There is a dotted line here. So I'm putting dotted lines where we go to radius 0. There's also one over here. So this is pi over 4. Right there. So this is between pi over 2 and pi over 4. That's like 3 pi over 8. Is that right? Yeah, 3 pi over 8 is there. And over here, you're looking at a 5 pi over 8. So there is 45. If I did this right, and I have not done this right, you can see I've not done this right, because I'm supposed to have 45 degrees from here to here. You know, there should be a 45 degree wedge. I don't think I'm quite 45 degrees there, do you? Like, is this 45 degrees? No, I haven't done a good job there. But let's see here, from pi over 4, so anyway, there's another one up here, between pi over 2. And so about pi over 2, there's another one. And let's see here.
This is gonna make a 4-loop clover.
And this is like 3, this is between pi over 2 and pi. There's one right at the middle of that, so that's, I'm gonna stop doing this. I think without a protractor, I'm not gonna be successful on the board, because there's too much error in what I'm drawing at the moment.
There you go.
It's not gonna help. Thank you. I'm being offered a protractor by the audience. It's good with 30 students here. Just somebody has a protractor. Sorry, lies. So anyway, the point is that there's a loop that goes out to 3 here. Let's suppose that's 3. So I'm going to call this point A, just for the sake of, this is A, all right? And then there's a pi over 4, right? I will allow myself this one and this one. This is pi over 4. This is 3 pi over 4. This is pi. This is 5 pi over 4. This is 3 pi over 2, also known as 6 pi over 4. And this is 7 pi over 4. Right, in terms of theta, pi over 2 up here. So my point is, this is A, and so B, check out B. B is tricky, because B has negative radius, right? You'd like B to be right here, right? But it's not, because R is negative, it's over here. See that?
So what happens to the pi over 8? Before
So the pi over 8 informs me on how it asymptotically, it tells me in how it approaches. So if I put those in, which I think I can do now, since I've got my marching orders halfway between this and that, that and that. So this is like pi over 8 and minus pi over 8 here. So basically that's telling you to draw the loop like this. It keeps the loop from being fatter.
Okay.
And what I just drew is this one. Right, then what happens is, let's see here. So minus pi over, so I'm trying to think about them kind of in their direction. And I'm putting this arrow in terms of how theta is increasing, right? I go from minus pi over 8 back to 0, and then
back to pi over 4.
Back to pi over 4, but except it's negative. So actually, instead of that, I swing through here. And I swing back like that.
And now you're at 3 pi over 8.
Right. And yeah, then I'm on, let me do some color coding here. So So on this loop right here, which goes, like you said, from 3 pi/8, which is so up here, 3 pi/8, 5 pi/8. So those are guidelines for this loop here to do it properly. And if you're doing this really carefully, get out a compass so you knew how far like the radius 3 circle was. My loops aren't quite the same because my fingers stretch different times I do it. And then I get the 5 pi/8, I'm for this next loop here, right? Which is between where? Between pi/2 and what's this? This is 3 pi/2 in the middle, right? So around about 3 pi/2, right? You would have well, that's the thing, is you'd have one up here, right, between pi/2 and I'm having.
So you just hit 5
That's
pi.
not pi. There's something wrong here. That's not 3 pi/2. This is not 3 pi/2. Nonsense. You can't have 3 pi/2 before pi. What is this? Dummy. Not you guys, me. Where did I go wrong?
6 pi.
That's supposed to be 3 pi/4. That's important because we're talking about that loop right now, which is centered around 3 pi/4. Whereas 3 pi/4 is over here, right?
Mhm.
So you'd like to put the loop over here, except r is negative,
So
so it goes over here. So instead you get, a loop down here. These should all be the same shape. Okay, I'm doing badly. And then, okay, so that's this one. And then, see, I didn't draw far enough, did I? You have to keep going, actually. Around pi, you've got another loop, right? Which I will foolishly make blue so no one can see it. So that gives you around pi. And then there is yet another one, here to here, and let's see, that's what? So this is pi/4, so this is 5 pi/4.
And you do that on the other side because it's so negative.
Yeah, thank you, and exactly, it would be down here, but it's actually over there. So I'll do blue again, just to make it invisible. I was watching a camera. Well, maybe my phone does better, I don't know. And then, you got the one, gotta keep going. Where is this? 3 pi/2, right? So finally, that 3 pi/2 loop comes in here.
And then you're 2 pi.
And then this one, yeah, we're over here to, plus another, is that 2 pi?
No, pi, your 2 pi should end at the top, right?
Yeah, I just, pi/4, that's 7 pi/4, right?
Yes.
And then, yeah, like up here,
That's your 2 pi.
that should be 2 pi,
And then that's back at the beginning.
yeah. And so at the seven, you got your one around 3 pi/2, we already got that one.
So
Here.
7 pi/4, and then it's on the negative side, so you gotta go top side.
So it goes over here. So anyway, if we did it correctly, 1, 2, 3, 4, 5, 6, 7, 8 times. Now, like pretty much if you go to 2 pi, you're gonna get the whole story, but there are certain graphs that before you get to 2 pi, it's already repeating. So you can stop at like pi. That happened with the one that I did in video at the end of last class. So, yeah, that's also not gonna help for I'm being offered a compass, which is probably not a good, I think I would scratch the board, yes. So I think I've shown you guys a good set of examples for these graph-wise, right? I think we're gonna, stop with these examples for now, and I'm gonna take the rest of class just to look at the solution to test two with you guys, since we have a little bit of time. That's okay?
Yeah.
Yeah.
So this is what y'all did, Friday.
Yeah, well, we also, we did other things, this was not the whole class, what did we do?
Sure.
Before that, it's videoed. So like, it's pretty good before that point.
I think we were just going
It's just the thing that's entirely visual that you need to see drawn out step by step is the part I didn't.
I mean, I
record.
understand this pretty well.
Good. This is not in the textbook. The textbook has tables.
Mm.
They don't draw the R theta graph, and I think that's a shame, because I think it's good to draw the R theta graph for a couple different reasons. One, most students currently taking this course need to practice how to graph sine and cosine. Because if you know how,
Makes your life easier.
it was forgotten on the first test. So, and maybe the situation's changed since then, right? But, I don't know.
I understand why the book didn't do it. That's a lot of time, like, to graph that. I mean, think about that problem took you, what, 20, 30 minutes?
Yeah, I mean, these take about 10 minutes a piece, something like that. Unless I get lost and then I can wander. But, if you guys are actually here, we can get back to the test. And yeah, this was a difficult test, so we hope you didn't do super great. Sorry, but it's understandable. I did curve at 20 points, so let's see here, what else do I have for you guys?
Who got a 130 then?
What's that?
Who got a 130?
No, I curved at 20 points. So
How does the curving work?
20 points is easier to add than an odd number, so kind of. It's not especially sophisticated.
Like, is there a way, like, so someone gets like a 1, like how would you take all the...
Well, I mean, I don't have to curve it at all. I mean, I don't always.
Yeah.
I thought that this particular test was difficult, so I thought it should curve.
It was.
Let's see here. Where are we? Recalculus trigonometry, right? And I just posted the solution just before class to test 2, so here it is. Oh, we're doing this again, are we?
The screen not getting over.
Yeah, I didn't want to extend, I want to duplicate. There we go. Yes, please. Okay, come on, figure it out. There we go. Haha. You will bend to my will. Let's see here. Try and get away side panel. Behind you side panel. No, fine. I'll save you. Come on, Adobe. Hello. Is it open? Another side panel. Ah. Curses, the side panels. Ah, finally. Yeah, that should be more or less visible. No. So I gave you guys some bonus points for attending. If you did attend that certain day, I forget what day it was. There's another one that I haven't put in the, and I'm putting these into a column called bonus
Right.
because, you know,
What, so quiz 5, the take-home quiz?
yeah, is actually quiz 5. I'm relabeling the bonus quiz as just bonus
Alright.
for the sake of, you know, not losing track of my proper numbering. And these are various things that I have been trying to get back to you guys for a while. And, so finding my office has become organized enough that I found all these things a second time
What
and
is
bringing them to you now.
What is this out of?
Oh, I don't know. That I do not know, right offhand.
Oh, it says 10 points.
Oh,
It's
okay.
My bad.
That's fine, mystery solved. Okay, so, here we go, let's just talk through this right quick. So problem number 1, pretty much just graphing, there's only one of these that's cosine, it's A.
Yeah.
The other two are either cosecant or secant. Secant is 1 over sine, so it has an asymptote at 0. This has to be the secant. Excuse me, the cosecant, because cosecant is 1 over sine. So that's why it's ABC, yeah. Sorry, if you were expecting something other than ABC, my apologies. So cosecant is 1 over sine, you're given sine is -1/2, so it's 1 over -1/2, which is -2. A number of you made this way more complicated, and unfortunately did not get it. Number 3, so I'm going to change this in class to cosine, cosine, sine, sine, because otherwise I have no earthly idea if that can be simplified, probably not. So once it's that, then that's cosine 5x minus 3x, or vice versa, depending on how you want to look at it, and that gives you cosine 2x. Through the adding sine identity, you get cosine 5x, sine 5x, cosine 2x, and from the product of cosine's identity, you get cosine of the difference plus cosine of the sum all divided by 2, which gives you that. So a lot of people did not get these, but you had the formula sheet, so I don't know what to say. Hopefully next time was better. So down here, I told you sine of A is 0, and we're looking at an acute angle, and B is 2/7, calculate cosine A plus B, so notice first of all we can figure out if sine of A is 0, and we're here, that means A has to be equal to 0. There's only one place where sine is 0 from 0 to pi over 2, that's at 0. So that means that cosine of A is 1. Generally speaking, sine of A being 0 means cosine can be plus or minus 1. It happens to be 1 here because of the context. But anyway, then we use the adding angles formula for cosine, and we get 2/7.
How's it writing, actually?
This is one of the problems on this test, which I think makes the test difficult. Problem 4 is a difficult problem. It's not, everything before problem 4, I think, was a walk in the park. Comparatively speaking, problem 4 required some amount of sneakiness. Problem 5. So I said to simplify in terms of cosine theta, you guys did not do that. You did other things like cosine 2 theta and
Yeah.
anyway,
That was
it's cosine squared theta. This one here, use trigonometric identity to simplify. Okay, so the thing is, sine squared theta is 1/2 of 1 minus cosine 2 theta. And so the 2's cancel, then the cosine 2 thetas cancel, and you get 1. So some of you had, if you use a trigonometric identity, but it wasn't this simple, I probably gave you only took off like a point or 2. If you're further away from a simplification, I took off 3 points. So there's partial credit that's given here.
I am so stupid.
Problem 7 is very, very much like the problem we either had in a quiz or a homework. So there was like, I'm trying to remember where it was, I think the corresponding, there was like a problem like similar to this, but with sine that we had, and so that's where I came up with this problem. And, yeah, I don't think anybody got problem 7. So,
I got negative cosine gamma equals 0. I think I was close.
Close. Negative cosine gamma equal, but that's not true. Cosine gamma doesn't have to be 0. All we know for sure is that cosine of alpha plus beta plus cosine of gamma is 0. I mean, it is true that cosine of alpha plus beta is equal to minus cosine gamma. I mean, that's true. But anyway, so it's just this, sum of the angles being pi, so you can replace alpha plus beta with pi minus gamma, and then use the adding angles formula for cosine. Sine of pi is 0, cosine of pi is minus 1, and you end up with minus cosine gamma plus cosine gamma, otherwise known as 0. Again, this was like the similar problem with sine, which I thought made this plausible. Again, there was a problem like this on a quiz or homework we talked about, problem 8, right? And a lot of you guessed the answer, several of you guessed the answer here without showing work, and I gave credit. But this is how you do it. Make a triangle, you know, tangent of the reference angle is opposite over adjacent, so I get pi over 3 there. That's the measure of the angle off the negative x-axis. I think more of you were successful in 8 and 7 for sure. Problem 9, some of you changed the tangent to sine, which, okay, that's a very fortunate mistake, but I gotta take off a lot because it corrupts the problem. It's problem nowhere near the same difficulty, right? So anyway, you draw the reference triangle, which here is got opposite side 1, hypotenuse x, and then that forces you to put square root of x squared minus 1 down here by the Pythagorean theorem, which then tells you that the tangent theta opposite over adjacent is 1 over square root of x squared minus 1. We worked a number of problems like this in class, and I think I had some on previous quizzes. Range of inverse function. Some of you put minus 1 to 1. That's unfortunate. That's the range of sine and cosine. But because of our customs, the range of inverse sine is minus pi over 2 to pi over 2, and the range of inverse cosine is 0 to pi. Everybody should have been able to get problem 11. Some of you didn't. This is supposed to be a gift, but it was not a gift that was freely taken. So like you literally just have to take inverse sine of this, inverse tangent of that, and inverse cosine of 2 of those. No, a lot of people got this. Like I was not able to slip this past you. Almost everybody got this right, no solution. But and more people got B than got A. Some people got A wrong and they got B right. Let's see here. Here's where it needs the most work. You guys need to work on these for sure. This I think was a quiz problem.
Yes.
So that's especially troubling that you guys didn't get that one. Again, the way to solve these is to graph the left-hand side and graph the right and see where they intersect. I mean, that's the easiest way I can think of. But anyway, pi over 4. And also pi over 4 is just the one you get from just taking inverse tangent of 1. You know, that's the first thing. You should always be able to get the inverse tangent of whatever solution. That's almost, you don't need a graph for that, right? You could have found in the same way we found for problem 11, one solution, provided that the domain given is allowing of that. And it usually is for me, because I want to give you guys things you can get partial credit on, even if you have only partial understanding, you know? But anyway, and then periodicity of tangent means add pi is going to give you another solution. So like there is a non-graphical method to solving problem 12 as well, I will admit. But solution I'm showing here is in concert with what I've shown you before in class, yeah. Cosine of 3x, there's a bunch of solutions here. We've worked a problem like this in class, for sure. And there they are. So This one is challenging, no doubt, right? This is, you gotta be careful. There's no way to do this problem quickly. This takes some time, for sure, right? Do carefully. Problem 14, at least one of you factored it correctly and then forgot to switch back to sine after you converted to the quadratic. Like, oh no! And part of the reason for that is probably because you used x for the quadratic, which is not a good choice. You should use something other than x, because x already has a meaning here. So if you're making a substitution, say something like y equals sine x, then you get 2y squared minus 1, y plus 1, then you get y equals either a half or minus 1, and you'd be less tempted to say that those are the answers, because you know you're looking for x. But, that was about you? Oh, sorry. Well, not you outed yourself, so
That's fine.
I won't repeat your name. I'll just say, if you're looking for jewelry,
That's fine.
Right.
That's a good one.
or if you're a, person of quite questionable character who's been selling some,
How about Subway?
Subway, yes.
Yeah.
Sorry, Subway. Not a sponsor. I really don't have any sponsors, right? Anyway, I think I'm about out of time here. Ooh, and then some, but, so, a lot of you got this one right. A lot of you got this one right. Hooray. Very happy about that. That is growth, for sure. And, a lot of you got these, parts of these right, and then parts wrong, so look at it and see when it's skewed. These ones will come back again on test 3 because I need to test law of cosines and law of sines again. So I would expect these problems appear again. Not these literal problems perhaps, but things like them. So anyway, I'll let you look at those. And then these. So that's it now. Wonder if I've got any battery left for my other class.